Right. Okay. Right. Good evening. We'll start. First, can you confirm whether I'm audible? Audible, right? Right. Okay, so this week you are just 15 weeks from the exam now, right? So we are having the 10th history discussion at a point where you are 16 weeks from the exam, right? Sorry, 15, not 16. You are 15 weeks from the exam, right? For last 2 weeks, I couldn't do the 2 or 3, I can't remember. For last 2 or 3 weeks, I couldn't do the history discussion because of some unavoidable reasons, right? And this week onwards, again, it will be resumed, right? And today, we are going to start off with elasticity, right? And after elasticity, the other main lessons rolling up will be matter and radiation, right? Then thermal parts, electricity parts, right? And special mechanics parts, right? So there are more things coming up, right? And regarding the papers, right? Regarding the papers, now since you are 15 weeks ahead of the exam, right? Still the paper class is going as the same structure with 6 essays and 4 structured essays, right? But last 12 weeks, you will be having full syllabus papers, full syllabus in the sense, last 12 papers will be having the exact same pattern, same structure as our LL paper with 8 essays, 4 structured essays, right? Now also you are writing 6 essays with 4 structured essays, right? The other 2 essays will also be added, right? Okay, so those are things, right? So when it comes to this time period of your life, this is the most critical and the important time period you got, right? It is going to change your entire life. I mean, the way you work during these 15 weeks, the way you behave during these 15 weeks is going to change your entire life hereafter, right? So that's the thing. Be very mindful and careful, stay focused, and you have to work being on the track, right? Work being on the track. Okay, then let's get into the discussion. Let me share my screen. Visible, right? If you haven't downloaded the questions, you can download the questions from the links that I have put to the channels, or else you can download it from the pin message in the live chat, or that is in the description, right? So from wherever you can get it, right? First one, a rod AB of length L1 is connected to another rod BC of L2, length L2, and the combined rod is subjected to a fixed stretching force F as shown, right? A fixed stretching force, it is not marked. Let's mark the force. Then it should be something like this. If both rods have identical areas of cross section, identical area, and the ratio of Young's modulus of AB to Young's modulus of BC is 2 to 3, right? Then simply AB is 1, then this means y1 y2 equals 2 over 3. This is a given data. y1 y2 equals 2 over 3. That is a given data, right? Then the extension produced by the rod AB becomes equal to that produced by BC when, right? So that is about extensions. This is our general equation. F over A equals elasticity, right? We have only one equation for Young's modulus, right? If Young's modulus is given with temperature difference, we have another equation. If Young's modulus is just given, the general equation is this: F over A equals Y E over L, right? Since we need something about E, I'm going to subject E first. E is given by FLOYA is given by FLOYA, right? Now let's apply this for these two. Then E1 equals E2. In this scenario, it says extensions are produced, extensions are equal, extensions produced are equal, right? Then F is same because they are in a series combination. F is same because they are in a series combination. Then if I plug these values, F, L1, this is for first one, right? Then Y1, areas, about areas it was given, identical, same A. Then same F, L2, Y2, A, right? F2, F, A2, A cancels, right? I know Y1 no Y2 as 2 over 3. Y1 no Y2 as 2 over 3. Then this L1 equals L2 times Y1 no Y2 no. Cross multiply this. Y1 no Y2 is 2 over 3, which means L1 equals 2 L2 over 3. 2 L2 over 3. Right? Answer 2. Right? Second one. That is an easy one. This is not the only way of doing this, right? So if you need, you can cancel the constants first and then get into the question. That's also fine. That's also a fine option, right? Anything, right? Let's move on. Second one. The red lines, see the red lines of the following graphs represent the extension versus load. W, curve of a light spring hung from a ceiling. When the load is hung from two such springs as shown in the figure, which graph represents the corresponding extension versus load curve? Right. Now, in the first scenario, only one spring is used. Listen, in this first scenario, only one spring is used. Right. In this second scenario, identical two springs are used. Identical two springs are used. Right. As that is given in that diagram. Identical two springs are used, right? Now, we know the point where this graph deviates from this initial linear variation is its elastic limit and the proportional limit, no? Right? The first limit is the proportional limit, and then we have the elastic limit, right? Now, the logic is this. Listen, the logic is this. If the same material is used for a same material, both proportional limit and elastic limit remain same, right? For same material, because they are constant for a material. Both elastic limit and proportional limit, both proportional limit and elastic limit, both proportional limit and elastic limit are same for the same material, right? Which means in both of them, this limit should be same. Now, this is our L-axis. This is our L-axis. Then elastic limit is on that L-axis, no? That is on the L-axis, right? Now, in this graph given, in fourth one, these limits are equal, right? In the first graph given, these limits are equal, right? In the first graph and fourth graph only, these limits are equal. Then all other three are wrong. I'm going to remove them, right? And about extensions, nothing to do anything, right? And we have to use some knowledge on springs, right? Some knowledge from springs, right? Where we have discussed springs, right? That is not under elasticity, but this idea is coming from springs and spring constant actually that we have proved under simple harmonic motion and springs, right? When the spring constant increases in parallel combination, spring constant increases. When spring constant increases, extension decreases, right? That is coming from our learnings in springs. In a parallel combination, spring constant increases. When spring constant increases, right? Extension decreases, right? Word ka use karana ngadi. When spring constant increases, x means extension decreases, right? Now, since they are in a parallel combination here, spring constant increases. When spring constant increases, extension decreases. Then compared to the initial one is given with this dotted line, no? Compared to the initial one, extension of the second scenario should be lesser compared to the first one, right? Now, if I compare 1 and 4, now my tie is between 1 and 4 now, right? Correct answer is 1. Because now, at the present scenario, extension should be less. It should be lesser than what we had in the first scenario. Because it is a parallel combination. In a parallel combination, k increases. When k increases, extension decreases, right? See how those things are linked together, right? So that is how those things are linked together, right? Next, third one, mercury will contract in volume by 0.01%. 0.01%. 0.01% means like this, no? 0.01%. Something like this. So this can be written as 10 to the power minus 4. This is 10 to the power minus 4. When subjected to a net pressure of 2 times 10 to the power 6. The bulk modulus of mercury is, right? So we know the equation of bulk modulus. What is it? Equation of bulk modulus. Equation of bulk modulus is, right, pressure over delta P actually. Pressure again, change of pressure, right? Let me write as delta P. Pressure, change of pressure, delta V. This is delta V over, right, strain of volume, right? Strain by volume, delta P over delta V over V, right? Proved equations. Delta V is given 2.6 times 10 to the power 6. And this is delta V over V. Mercury will contract in volume by this much. So this is actually, this is delta V over V. This is delta V over V. Then 10 to the power minus 4, right? So final answer 2.6 times 10 to the power 10 pascals, right? This answer is not properly printed. Correct this last answer as 10 to the power 10. Correct this last one as 10 to the power 10, right? That is not 10 to the power 17. This should be 10 to the power 10. Correct this answer, right? 10 to the power 10. Very simple. So we all know that any modulus is written as stress over strain, right? Any modulus is written as stress over strain. When it comes to bulk modulus, stress is written as pressure and strain is written as change of volume, right? Next, figure shows the variations of extensions E of wires X and Y. This is not given. This should be X. This is Y. It's a printing mistake. Sorry. X and Y. This is how it should be. With the applied force F, if one end of X is connected to one end of Y to form a long single wire, the variation of E with F for the composite wire is best represented by, right? Now there are two wires and these two are going to connect this way in series combination, X and Y, right? X and Y, something like this, right? Then observe this given graph here. Proportional limit, end of the, not proportional, elastic, end of the elastic limit of wire X is at this point, right? At a force B, at a force FB, right? And proportional limit of wire A is here. Proportional limit of wire B is here. Not proportional, elastic. Elastic limit of wire B is here. Elastic limit of wire A is here, right? Now, if we consider the region before FA, look at here. If we consider the region before FA, in this region, both wires are inside the elastic limits. No? Both wires are inside the elastic limits. Then even the composition, right, combination should be within the elastic limit, right? Because for a force FA, both are inside elastic limits. Then even if they are parallel, we know in series. Even if they are series, in series combination, we know always forces are equal in series combination, right? Throughout these rods, forces are equal. Then for force FA, it should be still inside its proportional limit or the elastic limit, right? Then up to FA, it should be a straight line. Up to FA, it should be a straight line, right? Then 1 is wrong. Up to FA, it should be a straight line. 3 is wrong, right? 5 is wrong. After FA, look at here. After FA, now here this is deviating from the proportional limit, but X is still inside the proportional limit and total extension is given by addition of two extensions of these two. No? Now, as an example, if I check this for a point somewhere here, if I check this for a point somewhere here, for a force somewhere here like this, force check. If I check this for a force here like this, now extension of wire x is this much, ex, and extension of wire y is this much, ey. Then resultant extension should be E total should be ex plus ey for the composition wire, no? Combined wire for the composition, right? It should be ex plus ey for the combined wire. Then always it should be greater than this straight line, right? Now in this one also it's greater than the straight line, right? And about this first answer, in first answer this slope is less than what is given here. When main slope then it cannot be the answer, because always the addition is coming as the total x, right? Totally is the addition. Then it cannot be something less than these given two curves. It should be something great slope, a higher slope than given two. So it is 4, right? See, simple logics, and use them properly. Simple logics, use them properly and accordingly, right? Next, one end of a wire of initial length L and cross-sectional area A is fixed to a ceiling, and the other end is attached to weight W as shown in the figure. When the attached weight is reduced by half, the extension of the wire is found to be reduced by length equal to L over 10. The Young's modulus of the material of wire is, right? Now we have two scenarios given, no? Which means we can apply our equation under these two scenarios, right? Equation F over A equals Y E over L, right? Now the extension of wire is reduced. About something is given about extension, let's subject extension first, because then easily we can subtract when I need this difference. Equals FL over IA, right? Now if I apply this for these two scenarios, say first one is E1, F is W, right? L is L, right? Y is Y. It is what we are going to find, right? And area is given A. For the second scenario, say E2, same weight, weight is reduced by half, then W over 2, same length, right? Y A, something like this. Now what is given is, it is reduced by length equal to L over 10. Reduced by length equal to L over 10. Then get the subtraction. Then it should be E1 minus E2. E1 minus E2 should be L over 10. E1 minus E2 should be L over 10. Right? We have E1 and E2 here. Then W L over YA is common, no? So I'm going to take it out. See, W L over YA is common. Take it out. Then from E1, 1 remains. From E2, half remains. L over 10. Then L2, L cancels. L2, L cancels. Right? Then here, W over YA remains. Simplify the bracket. 1 minus half is half. 1 minus half is half. Right? Equals 1 over 10 remains. 2 times 5 here. We need Y, subject Y. Y is given by 5W over A. 5W over A. Right? Then answer 3. Reduction is given. Since the reduction is given, right? I subjected D first and subtracted. Reduction and I think a difference right? Difference difference subtraction right? Next, 6. The material of the human bone has Young's modulus of 10 to the power 10 nm minus 2. It fractures when the compressive strain exceeds 1%. Compressive strain exceeds 1%, right? Then this given strain is 1%. 1% means something like this. So that is 10 to the power minus 2. Strain is 10 to the power minus 2, right? Because we don't need percentage values for the equation, but we need the actual value. That's why I converted that percentage to the value, respective value. The maximum load that can be sustained by a bone cross-sectional area of 3 times 10 to the power minus 4 is maximum load, right? Then let's apply our equation. F of A is y times E of L, right? Equations දෙකයිනේ මේ පාඩමේ තියෙන්නේ, right? F maximum load is asked, so F is asked. F over A, area is 3 times 10 to the power minus 4, 3 times 10 to the power minus 4, y 10 to the power 10, E 10 to the power minus 2, right? L, strain is given, then whole E of L is given, that is 10 to the power minus 2, right? That's it. Simplify this. F equals cross multiplication 3 times 10 to the power minus 4 minus 2 again minus 6 ne? Then 10 to the power 4, right? 3 times 10 to the power 4, it's 2. 3 times 10 to the power 4. Right, give me 1 second, take it down. Right, next one. 7. An elastic string has a length of 30 centimeters when the tension on it is 3 newtons, right? When the tension is 4 newtons, the length becomes 32. If the tension is increased to 7 newtons, the length of string will be, right? Simply, right? If we are to apply the equation, F of A is y E of L, right? Now, an elastic string has force is given, right? Let's apply for the first two scenarios given first. F is 3 over, say area is A, right? Y is not given. Then Y, the given data is length of an elastic string has a length of 30 centimeters. Length of 30, again total length. Initial length is not known. Then let's assume initial length as L. Then E should be 30 minus L. Total length is 30 now. Over L. This is the first one. For second one, 4 over A equals Y, right? It's 32. 32 minus L over L, right? So first you can divide these two. Divide these two. Then A to A cancels, Y to Y cancels, L to L cancels, right? Then what's remaining? 3 over 4 from here. 3 over 4, right? And from this side, 30 minus L. And from here, 32 minus L. Simplify this. Nothing cancels, no? Nothing cancels. Then 3 times 32, 96. Minus 3L equals 120 minus 4L. Then L equals 24 centimeters. Now L is known. L equals 24. Now, we can apply the same for the last scenario given. F is 7. 7 over A equals Y. 7 over A equals Y. E over L. Then length is asked now. Then let's assume that new length is capital L. Then L minus 24 over original length 24. Right? Now again, we can divide this equation with one of the equations we had before. Right? Divide this with one of the equations we had before. Right? Let me divide by 2. Right? Then this one over 2. Make it then 3. Ne? What we are doing is 3 over 2. Then A to A cancels, 7 over 4 comes. And from here, L minus 24 remains. And from second one, 32 minus L remains. 32 minus L is 32 minus 24. Again, 8. That is 8. Then 4 times 2, it is 14. 14 equals L minus 24. So L is 38 centimeters. L is 38 centimeters. L is 38. Right? So this is how we can do if you apply equations. If you just apply our general equation. Right? There is another way of doing this. Take this down quickly. There's another way of doing this. That is this. See, you can also do this like this. You can also do this like this. See, now what we can do is, what else we can do is, listen, what else we can do is, now from the equation f over a equals y e over L, right? First check what is constants, what are the constants here? Check what are the constants here. Force is a variable, but area is a constant. Cut it off. Y is a constant, right? Cut it off. And L is also constant. L is also constant, right? L is also constant, which means for this scenario, F is proportional to E, no? For this given scenario, F is proportional to E. F is proportional to E. Now, if I apply it for the first two scenarios, when the force is 3 newtons, the length has been 30 centimeters. When the force is 4, length is 32, which means for 1 Newton, length increases by 2 centimeters. No? For 1 Newton, right? For 1 Newton, length increases by 2 centimeters. Now, if I need 7 Newtons, the difference between 3 and 7 is 4. Difference between 3 and 7 is 4. Difference between 3 and 7 is 4. Then for 4 Newtons, it should be increased by 2 times 4, 8 centimeters. Right? එහෙනම් කෙලින්ම මෙතන ඉඳන් මෙතන තිබ්බේ 30 නම් if initial length was 30, it should be increased by 8 centimeters. So it should be 38. එහෙම ගන්නත් පුළුවන්. It should be 38. Right? Another easy way of doing it. And if you saw that way. Otherwise, the traditional way of doing the question is you can apply the equation. Right? You will get the answer. Right? But this is MCQ. So this method is recommended. This is MCQ. This method is recommended. This is recommended. Right? Take it down. If we know the extension per unit force, right? Then if you know the difference in the force, then accordingly, right, proportionately, it should be extended proportionately. It should be extended proportionately. Right? Next. One end of a metal wire of length L and cross-sectional area A is tied to the ceiling. One end of a metal wire of area A is tied to the ceiling. The other end is connected to a massless spring. This end is connected to a massless spring of a spring constant K. A body of mass M hangs from the free end of the spring. Right? This hangs mg. Free end of the spring. If the Young's modulus of material of wire is y, the total extension of the system is right. So again, this is a series combination. This is a series combination. In series combination, forces are always equal. Right? Forces are equal. Now, if this is mg, right? Say this force is F. This is also F. At this end also, this is F. Right? This is F. Forces are equal. Right? Now, for wire and spring, you can find these extensions separately because total extension is, right? Total extension of the system is the sum of extensions of these two. No? For wire, we can apply F over A equals Y E over L. For wire, F over A equals Y E over L. F is mg, right? Then A is given A, Y is given Y, right? I need E. Say this is E1 over L. Then from this, E1 equals mgl over ya. E1 is known. Now we can apply for spring also. Then for springs, the relevant equation is F equals Kx. Hooke's law, F equals Kx. F is mg, still F is mg, right? K is given as K, right? Extension, say that is E2. Then extension of the spring is mg over K. Mg over K, right? Now total is the addition, that's it. Then E total equals E1 plus E2. E total is E1 plus E2. Now mg is common, no? Mg is common, take it out. Mg is common, take it out. Then from the first one, sorry, mg is taken out, L over Ya remains. L over Ya plus from the second equation 1 over K. L over Ya plus 1 over K. Right? It's 3. It's also a normal one. Next. 9. A uniform wire of length, it should be L. A printing mistake. L, that's L. Right? It should be L. Correct these things. Right? This should be L. Of length L. Attains a proportional limit when a mass M. When a mass M is hung from the other end. If L over 2 length of the same wire is used, the proportional limit will attain when the mass hung is, right? So in the first question also I told you this. Nothing to do anything. In the first question also I told you this. If the material remains same, limits are same. If the material remains same, if the material remains same, if the material remains same, right? Both proportional and elastic limits remain same, right? This is the logic. If the material remains same, both elastic and proportional limit remain same. Now, if this wire attains the proportional limit when the mass M is hung, right? Even if L over 2 is used, right? Proportional limit is attained when the same mass is hung. When the same mass is hung, right? Because that's the same material. That's the same material. Same material. Right? This is the logic. This is the logic. Nothing to do anything. Right? No need to do anything. Nothing to do. Right? So in the first question also I explained the same logic. 10. An aluminium Young's modulus 7 times 10 to the power 10. Linear expansivity 2.5 10 to the minus 5. Cylinder A of length 10 centimeters and cross-sectional area 20 square centimeters is to be used as a spacer between two rigid walls as shown in the figure. At 30 degrees Celsius, it just slips in between the walls. At 30 degrees Celsius, it just slips in between walls, right? So which means that is just satisfying the gap between these two, right? At 10 centimeters originally, right? When it warms to 34, the force exerted by the cylinder on wall is, right? By cylinder on wall. So on cylinder, this force will be exerted. On the cylinder, this is how the forces are exerted, right? Equal and opposite forces of this will be on the wall, like this, right? Then in the theory class also, under theories, I told you that if temperature difference is given, we have only one equation, so that is very straightforward. If a temperature difference is given, we have only one equation. F equals, we proved this in the class, F equals, if temperature differences are given, F equals Ya alpha theta. F equals Ya alpha theta. Then force is asked, right? Plug this. Y is given 7 times 10 to the power 10. 7 times 10 to the power 10. Area 20. Convert that to meters 10 to the power minus 4. Alpha was 2.5 10 to the power minus 5. 2.5 10 to the power minus 5. Theta 34. 30 to 34, it's 4 degrees Celsius. Right? Simple. Right? Simple. Then let's simplify this way. 10 to the power minus 4 and minus 5, minus 9 altogether. If minus 9 is cancelled, only 110 remains here. Only 110 remains. Then F equals, isolate the 10 to the powers again, isolate 10 to the powers, only 110 remains. When we 10 again, then this 10 with 2.5 is 25. 25 times 4 is 100. Then here 7 times 2 is 14. Then 14 times 100. That's it. 14 times 100. Then 1.4 times 10 to the power 3. 1.4 times 10 to the power 3. That is the first one. It's a simple one. Again, the equation is very straightforward. Equation is very straightforward again. Next. A uniform elastic wire is suspended vertically from the ceiling and mass is hung from the bottom end. Consider the following statements, assuming that the proportional limit of wire is not exceeded. Proportional limit is not exceeded. Right. A uniform elastic wire. First one, if the length of wire is doubled, the strain of the wire doubles. Right. See? So in that scenario, we know F over A equals Y E over L. F over A equals Y times E over L. Right. And a mass is hung from the bottom. Right. Consider one says, if the length of the wire is doubled, see, if the length is doubled, if this length is doubled, if the length of the wire is doubled, the strain of the wire doubles. Strain kill again, may part strain is E over L. If L is doubled, this will be halved because they are inverse. If L is doubled, this will be halved. So it is wrong. That is inverse. That is inverse. Second one. If the area of cross section of wire is doubled, the strain in the wire doubles. If area is doubled, right? Area is here. Area is doubled. When area is doubled, again strain is halved. Strain is halved because they are again inverse. They are again inverse. That is halved. So that is also wrong. That is also wrong. Right? Next one. If the hung mass is doubled, the strain of wire doubles. If the hung mass is doubled, which means about F no. If F is doubled, yeah, E over L is also proportional, then it doubles. F to E over L, proportional, it doubles. Then C is correct. C is correct. Which means the answer is only C. Answer is only C. Only C. Right? Next. 12. A mass is attached to the lower end of vertical elastic string, which is rigidly fixed at other end. The mass is then moved down with a constant velocity by applying a force F. The variation of F with time t is best represented by. Okay. It is moved with a constant velocity. Right. When it moves with constant velocity, we know S equals ut, no? The S equals ut because I need to connect this with length. Then S is length. Length equals, say, velocity is vt. Right? This is the variation now. This is the relationship now between the length and this one. Right. Now, let's check by applying an equation. We don't have multiple options. We have only this equation. F over A is Y E over L. F over A is Y times E over L. Right? A mass is attached. So that is a constant. Say M is attached, mg. A. Right? Y is Y. And E. Now, if final length is, let's assume final length as capital L. Let's assume simple L. Let's assume final length as simple L. Then the initial length as L naught. So this is L minus L naught over initial length L naught. Right? What are variables? F and T. Don't write this as mg then. It is given just as F. I make mg and so let's keep it as F. Let's keep it as F. Right. Now, to plot the variation, subject Y. Y is F now. Y again. Y axis. Y axis is F. Y axis is F. Then isolate these variables and see. A, Y, L naught. L minus L naught. For L, we can write Vt. Then Vt minus L naught. Vt minus L naught. Vt minus L naught, right? Then F equals ay V over L naught T minus L naught to L naught cancels minus ay මෙන්න මෙහෙමයක් එනවනේ. Identify the variables. T is x, right? Then whatever it is as a product with x should be gradient. This is y. Then this is c. So the correct equation is mx minus c. But from you, even that is not expected. That is mx minus c. The only mx curve given here is 1, right? Now it looks like it goes through origin, but it doesn't go through origin, right? It should be a little bit below the origin. It's not going through the origin. That is mx minus c. That is mx minus c. Next. 13. The material of wire X has a higher value of Young's modulus than material of wire Y. X has a higher value of Young's modulus. Then Yx is greater than Yx is greater than Yy. When the two wires are subjected to same tension, the extension of wire X is found to be more than that of Y. Extension of wire X is more than that of Y, right? That of wire Y. Consider the following statements, right? Now let's apply in the equation and check this, because I need to cancel the constants and going to focus only on variables. F of A equals y times E of L. F of A equals y times E of L, right? Now it says it is subjected to same tension. So F is same, right? Then area is not given. Nothing about area is given. The material of wires, right? When the wires are subjected, about length also nothing is given, right? That's it. Only F is constant. Then the above will happen if diameter of, okay. Then let's keep the equation as, after cross multiplying, let's keep the equation as L over A proportional to L over A E times Y, no, sorry, E times X, E times Y, no, E times Y. L over A is proportional to E times Y, right? Now you can check this out using this. First one, the above will happen if the diameter of wire X is smaller than that of wire Y. Diameter. If diameter is smaller, cross-sectional area being smaller. If diameter is smaller, cross-sectional area being smaller, right? The above will happen if, right, again, if both y and E of X is higher, right? If both y and E of X is higher, right? So simply this side of the equation is Ey, so it should be higher. We are checking that product, right? First one, the above will happen only if the diameter of wire X is smaller than that of wire Y. If diameter is smaller, if diameter of wire X is smaller, listen, if diameter of wire X is smaller, right, it is true that product Ey is going to increase. But without knowing anything about L, we can't conclude anything. It doesn't say anything about L. So you don't know how L changes. Then you can't say anything. So we can't say the above will happen only if, no, because we don't know what about L. Then this is wrong. B, the above will happen only if the ratio original length to diameter. Ratio. This is the ratio. Original length to area means original length to diameter, no? Area can diameter, right? Because inside A, you have this thing. If diameter is D, 5D squared over 4, then that is same as area. Is higher than that of Y. If this ratio L over A is greater, then this side is obviously greater. If ratio L over A is greater, L over diameter L over A is greater, right? For sure product Ey is greater, so it is possible. See, the above will never happen if the length of wire X is shorter than that of Y. If length of wire is shorter than x is shorter than. If this is shorter, this reduces. But the thing is, again, without knowing about A, you can't conclude anything. Without knowing anything about A, you can't conclude anything. So we can't conclude this. Right? Wrong. Then only B is acceptable. Only B. Only B. Logical. Right? Only B. Logical. Next. 14. Consider a situation where weights W is placed on a vertical rods of R, 2R, 3R and 4R respectively and made of same material as shown in the figure. If rods have the same length, not attain the proportional limit, variation of the compression delta L with R. Okay. Compression with R. Compression with R. Then let's apply our equation. F over A equals Y E over L. F over A equals Y times E over L. Right? F is W. Area is 5R squared with the radius. Right? Y. E is given as delta L. Right? Compression. Compression delta L over L. Right? Now our Y axis is delta L. So subject delta L. Then delta L equals, and you can identify variables now. Delta L equals W L over 5Y 1 over R squared. I isolated the variable. WL 5Y R squared. Right. Then R is our x axis. Then 1 over R squared should be 1 over x squared. Whatever it is here as a product is a gradient. And this is y. Y equals mx squared. M 1 over x squared is a standard curve. That is a standard inverse curve. So it should follow the inverse shape. What is the inverse shape? Inverse shape is this. It should follow the inverse shape. It should follow the inverse shape. See, it should follow the inverse shape like this. Inverse shape. That is only in equation 1. Sorry, the answer 1. That is only in answer 1. The inverse shape. This is in the inverse shape. Which one? Graphing. That is all about graphing. All about graphing. Right. So recently we had the graphing seminar also. Right. I mean, I had the seminar for 27 batch, but batch doesn't matter. Any one of you can join, and you joined actually. If there's anyone who are still not comfortable with pulling graphs, you can watch it. That's still there under live, right? It was a live stream video on YouTube. So you can watch it and grab graphing if you are not comfortable with graphing yet, because you will be getting 10 graphs for the exam. 10 graphs means in MCQ. Only in the MCQ, you will be getting around 10 graphs, right? Other than that, in structure essays, you have graphs, and essays, you have graphs altogether. The allocation for graphing in our paper is around 15%. Allocation for graphing in our paper is around 15%. That's a huge amount. That's a huge amount, right? 15. The force required to increase the length of an elastic string by unit length is given by, it should be K, not K, it should be K. Consider the following statements made about K. The force required to increase the length of an elastic string by unit length. To increase by unit length, increase by unit length. To increase by unit length, right? Then F over A, Y, E over L. To increase by unit length, no? Then unit terms are the denominator terms. Then I'm going to take this with the denominator and correct this equation like this. F over E. This is what they are referring. Force to increase E by a unit value. Force to increase E by a unit value. That is F over E as a ratio. F over E is given by YA over L. No? Now this is the force they have referred as K. This is the force they have referred as K. This is the force they have referred as K. Right? Now we can check these statements given. A. The value of K can be increased by increasing the Young's modulus Y of material. Right? If Y increases, K increases, yes. They are direct proportional. It is correct. It is correct. Right? Then second one, the value of K can be increased by increasing the cross-sectional area of string. Cross-sectional area, higher the cross-sectional area, higher K. That is also correct. See, the value of k can be increased by decreasing the length of string. By decreasing the length of string. Yeah, since that is here at the denominator, if length decreases, right, this side increases, so k increases. This is also correct. This is also correct, which means all A, B, C are correct. All A, B, C are correct. Right? See the pattern of questions. See the pattern of questions. But always we are doing like very much the same thing. Very much the same thing we are doing. Right? 16. In this graph 16, there was a small mistake. First, correct that mistake. This second graph should be like this. Right? This graph should be coming to somewhere here. It should be coming to a point here, not the origin. Should be coming to a point here. Right? So it's a typing error. This is how it should be. Right? It should be coming to a point here like this. This is how this second graph should be. Right? This is how this second graph should be. Please make that correction first. Okay? We learned this on the theory. This is called the hysteresis loop. Right? This is called the hysteresis loop. Right? But in this hysteresis loop, that is not coming to the origin. Right? Usually, a hysteresis loop is coming to the origin. But here, this is not coming to the origin. That is how it was given in the original exam paper. Now, when it is typing here, the typist has done a small mistake. That's why. Right? Correct it first. Right. 16. The figure shows a force extension graph for a rubber band. Consider the following statements. A. The rubber band does not return to its original length after stretching. Yes, because this part is remaining. This part is remaining. This is E. That is not C, that is E. Right? This is called a permanent set. We learned this. This is called a permanent set. Right? So it is not returning. That is a permanent set. That's a permanent set. Not returning. Not returning. That's a permanent set. So this is correct. B. The magnitude of total work done during increase of length is less than during increase of length. We know work is given by area under curve. Area under curve with e-axis. Right? Work is given by area under curve. Right? Then area under loading curve is this much. See, loading curve is this one. Loading curve is the increasing curve. Increasing length means loading. Right? So this is the area. Then that's the work. That's the amount of work done when loading. And area under this curve is area under unloading curve is only this part. This is the unloading curve, no? So area under unloading curve is only this part. Area under unloading curve. So you can clearly see these two areas are different, and area in unloading is less. Area in unloading is less. Area in unloading is less. So what it says is the work done during increase in length is less. No. When decreasing length is less. When decreasing length is less, then this is wrong. See, heat can be generated in this process. Yes, because we know some energy is remaining. මේක තමයි reason එක මම class එකේ කිව්වා. Because some energy, exactly the energy which is equivalent to this loop, that is called the hysteresis loop. Energy that is equivalent to this loop remains. Right? Some energy still remains in the system even after this process. Right? It remains in the system. Because of that energy, this system is heated. The system is heated because of this energy. Right? So this is the heat energy. This is the heat energy produced in the system. Right? So therefore, C is correct. So that is A and C. That is A and C. That is A and C. Right? Hysteresis loop. Hysteresis loop. Next. 17. A heavy metal box is to be supported by n number of uniform identical legs. A heavy metal box, something like this. The main box. This box is supported by, right? Box is supported by n number of identical legs. N number of identical legs like this. It is supported by n number of identical legs. n number of identical legs like this, right? Same material, identical legs of same material in such a way that the entire weight of the box is equally distributed. Entire weight is equally distributed in all legs. In this situation, the variation of the contraction delta L of leg with the number of legs, again graphing, right? Question is all about graphing now. Okay, then consider this equilibrium. Let's assume this weight as mg, right? This weight as mg and force on one leg as f, such n times of legs are there, n number of legs are there, right? Then using vertical equilibrium, vertical upwards forces equals vertical downwards forces. Vertical upwards we have the force by the rod, right? There are n number of rods, then it should be n times f equals mg. F can be expanded because we know f over a is y times e over L. So using this, f can be expanded. F is ay e over L. Then this is n times f should be ay e over L equals mg. Identify our variables, right? E is not given as E is given as delta L. Right? Then E is given as delta L. Replace E with delta L. E is given as delta L, no? Right? And subject delta L because that is my y-axis, delta L. And cross multiply this mgl over a y times 1 over n. A y times 1 over n, right? Then you can identify these variables. This is done. Delta L is my y-axis and n is x-axis, so that is 1 over x. Whatever it is as a product is a gradient, that is gradient. Then our shape is m1 over x, that is a standard curve. Again, a standard inverse curve, right? So it should follow the inverse shape. Answer 2. Right? All about graphing again. Right? Nothing beyond graphing. It's all about graphing. Next. How about this question? There was a mistake, printing error in the question. It should be corrected. First, I will correct the question. This is how it should be. As shown in the figure, a device is to measure the magnitude of force by applying it to a uniform metal rod of length L and area cross section A, and measuring the resultant compression delta L is the Young's modulus of the material of the rod, right? Then the other part should be added to the question, right? If least count of measuring instrument, is delta L naught and minimum measurable force is F naught. Then length of rod is question. Then length of rod is, right? This part was missing. That's a typing error. This part was missing. You can correct this part and add it here, right? Add this here, right? So these two are very important. Least count of this instrument is delta L naught, and the minimum force to be measured, minimum possible force to be measured is F naught, right? Minimum possible force to be measured is F naught, right? Then apply the equation. Now this is the point. If minimum force to be measured is F naught, right? If minimum force to be measured is F naught, they should measure a force which is greater than F naught. No? They should measure a force greater than F naught in order to do this. Should measure a force greater than F naught in order to do this. Right? Then the force measured should be greater than F naught. The force measured should be greater than F naught. It should be greater than F naught. Right? Then we can expand F. We can expand F here using our equation, because we know F over A is given by Y E over L. F over A is given by Y E over L. So F is Y A E over L. F is Y A E over L. Right? And I expand karamo. This F is Y A. Right? E is extension. Now minimum value to be measured is delta L naught. No, so it should be delta L naught. Minimum extension measurable. Minimum measurable extension delta L naught over L greater than F naught. Right? Greater than or equals greater than or equals, because minimum value to be measured is F naught. No, then it can be greater than or equal. F naught is also measurable. Minimum value is F naught. Right? F naught is also measurable. Then it should be greater than or equal to F naught. Now L is asked. Subject L from this equation. Subject L from the equation. Subject L from the equation. Then one second. The least count is L naught, delta L naught. No. My argument is wrong. See, let's argue this way. Our equation is F over A equals Y E over L. No? Now, minimum measurable value here is minimum measurable F here is F naught. Then minimum measurable F here is F naught. Over A, right? Over A. Y minimum measurable, this is delta L naught. Then these two should be corresponding. Then L. Now, this is the minimum force, no? F naught. Minimum force is this one, F naught. Now, from this, we can subject the minimum length. Minimum length of length. Subject karo. Then length is given by what is coming? If L is subjected, Y delta L naught over Y delta L naught A over F naught. Right? Now, which means minimum L here is Y is given as E. Y is given as E. Then EA over F naught. Delta L naught. Right? So this is the minimum length to be there. Minimum length. Right? Any length greater than this length can be measurable. No? This is the minimum length. This is the minimum length. Now, this is the minimum length because I have plucked the minimum values of F naught and L naught. F naught and E. This is the minimum length. Then any measurable length, then any length to be measured using this, should be greater than or equals to this minimum length. Should be greater than or equals to this minimum length. Then any measurable length should be greater than or equals to L min. L min is found here EA over F naught times delta L naught. Right? So that is 1. Right? That is a little bit logical. Right? Hope it's clear. And that's all questions I have arranged for today. Right? That's all questions I have arranged for today. Then I think we have around 37 or 38 questions from elasticity. So I'll be allocating another day for elasticity to discuss the rest. right? So I always want to do this S2A session as a session that you can join in a relaxed manner, right? This is not like a usual class, regular class, right? So I'm also doing this after some classes on the day, right? After 2 classes I had on the day, right? And for you also, it should be something that you can do in a relaxed manner, right? When you are staying your leisure time, free time around the home. So you'll be using around 1 hour, 1.5 hours for these S2A things, right? So that's why I arranged only 18 questions for today, right? And I'll be discussing the remaining questions next day. Any questions about these 18 questions we discussed today? Any questions about these 18 questions we discussed today, right? So if not, we can wind up. We have come to the end of all the questions. You can ask if any questions. You can ask if any questions. Is there anything? Or is it all clear? Is there anything? Or is it all clear? But if any questions, you can ask, right? So if not, we can wind up. No. Good. All clear, right? Okay, good. So it seems no questions. Reminding again, you are just 15 weeks from the exam now, and 15 weeks and 2 days, right? This is almost the end of Friday, right? Almost the end of Friday. We are almost on Saturday now. So your remaining time is exactly 15 weeks and 2 days, right? This Monday you are starting the 14th week before the exam. This Monday you are starting the 14th week before the exam, right? This Monday you are starting the 14th week before the exam, right? So time is flying, right? Time is flying, time flies, and utilize this high time just 3 months before the exam wisely. Use it wisely. Use it wisely with the full focus, right? Don't lose your focus, because just 14 weeks and it is going to decide your entire life, right? That's the thing. It determines your, it decides your result decides your degree course, and that degree course decides your field, and the job path decides your salary, right? Salary decides your lifestyle, right? So everything matters, right? So utilize this time wisely, right? And you can get all the updates about free sessions, free seminars, and S2A sessions, anything from my channels. Stay connected with the channels, and you can get all updates, right? Even if you are not a regular class student, that's totally fine. You can get all updates about these free sessions through my channels, right? Okay, then if no questions, we'll wind up. Work hard and stay safe. Good night and goodbye. See you in the next class, right? Goodbye.